Good morning, students. Hope you all are well. Today we are going to learn the common factors. So, first of all, what are the factors? What is the meaning of factor? Suppose we are taking a number 24. So, what are the factors are there? The numbers which will divide 24, they will be
And
called
let's
as
do
a
the
factor
method
of
very
24.
quickly.
So, definitely one will get
So
as a
whatever
factor
we
of
are
24,
getting,
and one is
you
a
can
factor
see
for
here in the
every
video.
number. And then 2 12s are 24 we are getting. Then
And after
3
that,
8s
we'll
are
be
24.
writing all the prime
4
factors of
6 are 24.
620,
Then
720 and
5, it
840
doesn't divide,
separately.
so 5 will not be a factor. Then we are coming 6. When we are getting the pair of the written digit, that means 4 6 are 24, and we have come up to 6. Then no other extra factors we will get unless the pairs for the written digits. So pair for the 4 I have written. Now pair for the 3, that is 8 I will write. Then 12 I will write, which is a pair of 2. Then 24 I will write, which is a pair of 1. So no other digit I should check whether it is a factor or not between 12 to 24, between 8 to 12, or between 6 to 8. Because once we have obtained the first pair, then no other extra digit will be there, only we will be getting the pairs only. Similarly, if I find the factors for 32, so what we will be doing? 1 32s are. So 1 obviously they will be there as a factor of 32. Then 2 by 2 it is going, so 2 is a factor for 32. 3 is not a factor. Now 4 obviously 4 8s are 32, so 4 is a factor. Now 5 is not. 6 is not a factor, because if 32 is not divisible by 3, so definitely it will not be divisible by 6. So when it is decided that it is not going by 3, so it is already decided that by 6 9 it will not go, or by 12 also. So after 6 7 is it is not going, so we are getting 8, which is a pair of 4 8s are 32, right? So we have obtained the first pair. So once we have obtained in one pair, so we will not be getting any other extra digits other than the pairs of the written digit. So 4 8s are, so the pair of 4 we have got. So what is the pair of 2? 16 2s are 32. So 16 is the factor. And what is the pair of 1? That is 32. So this is the way to find the factors, all factors of a number. So now we have to find what are the common factors between them. Can you find the common factors between them? You see, 1 is there common, 2 is common there, 4 is also, and 8 is also common there. Okay, so let's write the common factors of 24 and 32 are 1, 2, 4 and 8. Okay, these 4 are the common factors between 24 and 32. So we have to find now the highest one. If I want to find the highest common factor, so what I will be writing? That is 8. So the highest common factor of 24 and 32 is 8. And this highest common factor is known as HCF. HCF of 24 and 32 should be 8. In the last video, one thing I have said, that to check whether two numbers are co-prime or not, you need to check the HCF. HCF should be 1. That HCF means the highest common factor, what we have learned today. So if the HCF of two numbers, you are not getting any common factors between them, so definitely 1 you will get. So the HCF you will get as 1, that is your co-prime numbers. Now, many ways are there, many methods are there to perform this HCF. This one, what we have discussed, that is the very basic and definition method. Okay, and now many other short methods are there to find this HCF. Otherwise, if a big number is given, so it is not possible to find all the factors for that. Okay, so first method we are going to discuss, that is prime factorization method. Prime factorization method. So last day you have understood what is prime factorization. If you have not understood, then listen here. Suppose for the same number I am going to perform the prime factorization method. 24 I am taking. So I will be factorizing that 24. So when I am factorizing that 24, I cannot give any number other than prime numbers. So it's going by 2 and 2 is a prime number, so let's give 2. 2 12s are 24. Again it is going by 2. So 2 6 are 12. Again either 2 or 3 we can give. 2 3s are, then 3 1s are. Okay, this is the prime factorization method where we have taken all the prime numbers only as a factor. Listen here, 24 is also divisible by 4. So can we give 4 here? No, because 4 is not a prime number. So in case of prime factorization method, we have to give the prime numbers only as a factor. So 24 can be written as 2 into 2 into 2 into 3 into 1. These factors, if you multiply, you will get the 24 only. Now for the 32, if I do the prime factorization method, so again 2 16s are, again 2 8s are 16, 2 4s are 8, then 2 2s are 4, again 2 1s are 2. So for 32 we are getting all the factors as, all the prime factors as 2. So 5 2s are there and 1 1. So if you are asked to do the prime factorization only, you should not give this 1. But when you are doing the HCF, or later will be doing the LCM, so that time you should multiply this 1, because if there is no common factor, then at least 1 should be there for getting a common factor. Okay, so in case of finding the HCF, you multiply 1, though it is not a prime number. Okay, so now what we will be taking, the HCF of 24 and 32 is equals to, so we will be taking the common part only. 1 2 is common, another 2 is also common, and the third 2 is also common. Any other common part is there? No. So 2 into 2 into 2 will be the HCF, that is 8. So 8 is the HCF of 24 and 32. This way you have to perform the prime factorization method. Let's understand the process with one more example where we have to find the HCF of these three numbers, 72, 120 and 192. Now, if we start the prime factorization of 72, first we will be giving the 2, because 2 is a prime number and it is going by 2. So 2 36 are 72. Again by 2 it is 18. Again by 2 it is 9. Then 3 3s are 9 and 3 1s are 3. So this is the complete prime factorization of 72. So 72 is equals to 2 into 2 into 2 into 3 into 3 into 1. Now for 120, 2 6 are 12, then 2 30s are, 2 15s are, then 3 5s are 15 and 5 1s are 5. So 120 can be written as 2 into 2 into 2 into 3 into 5 into 1. Another 192, if we factorize this one with prime numbers, then 96, then 2 48s are, 2 24s are 48, 12s are 24, 6. This one is the complete prime factorization of 192. So 192 can be written as 2 into 2 into 2, then another 3 2s are there, into 3 into 1. 1 2 3 4 5 6, 6 2s, 1 3 and 1 1. 1 2 3 4 5 6, 6 2s, then 1 3 and another 1. Now you will be finding the HCF. HCF equals to the required HCF equals to, what are the common factors you find first? 1 2 is common, another 2 is common. So 3 2s are there common in all the three numbers, and another 3, the factor 3 is also common there. So the HCF will be 2 into 2 into 2 into 3 into 1. 1 is also common. So that is 24. So 24 will be the HCF. This is the process of prime factorization for finding HCF of given numbers. Now let's discuss another method, the method 2. that is division method. Suppose we have to find the HCF of that three numbers only, and what we will be doing here, we don't have to give the prime numbers, but we have to give a number which is a factor for all these three. Like first we are giving by 2, so 2 36 are 72, 60s are 120, and 96 are 192. So it is divisible by 2. All the three are divisible by 2. So we have to continue this process until we are getting any of them is not divisible. So next again 2 I can give, right? So 2 18s are 36, 30s are 60, and 48s are 96. Again by 2 I can give 9 2s are 18, 15 2s are 30, and 24 2s are 48. Now see, this one is going by 2, but these two are not. So we have to give a number such that all three are divisible here. Okay, so let's see, 3 is a number which divides all the three numbers which are inside. So 3 3s are 9, 3 5s are 15, and 3 8s are 24. Okay, now let's see here, 3 5 and 8. Out of that, 3 and 5 are the prime numbers, so nothing will be the divisor here which will divide all the three all together. So we have to finish up here only, and we have to take these numbers only, okay, as the HCF. So HCF of 72, 120, and 192 is equals to 2 into 2 into 2 into 3, that is 24. Now we have given here all the prime numbers, but it is not necessary to give the prime numbers only. We can do this one as giving the 8 only. So 8, if I directly give 8 here, 8 9s are 72, and 8 15s are 120. Now 8 2s are 16, 32 is there, so 24 will get. Then we are giving 3 3s are 9, 3 5s are 15, 3 8s are 24. Okay, so the HCF here we will get 8 into 3, that is 24. Here it is allowed because we are not doing the prime factorization, we are using the normal division method. So here it is allowed, but in prime factorization you cannot give this 8 because it is not a prime number. This is the division method. Now the third method is long division method, where we will be actually dividing the numbers in a different way. For example, if I have to find the HCF of the same numbers only, was 72, 120, and 192. We have to find the HCF of them. So we will be taking any two of them first, and we will start the division. So 72, 1s are 72. So what is the remainder here? 8, and then 4. 48 is the remainder. Now once we get the remainder, which is less than the divisor, now we will not be taking the fraction or any decimal point. What we will do, we will make this remainder as a divisor, and we will make the divisor as a dividend. The remainder will become the divisor, and the divisor will become the dividend. Now 48, 1s are 48, once again we are getting. So if I subtract this one now, 8, 4, 12, 1 will carry here, so 24. Now 24 again we have got less than this 48. So this is the remainder, and remainder will become the divisor now, and the divisor will become the dividend. So 24, 2s are 48. Now you have your division is finished now here. So once it is finished, so the HCF will be the last divisor that you have got. So HCF of 72 and 120 you have got 24. Okay, now what you will be doing, that HCF and the third number you will be doing the once again, so that you have to find the HCF of 24 and 192. Whatever HCF next in the next portion you will get, that will be the HCF for all these three. Okay, so let's start 24 and 192. So 24, if you multiply with 8, 24 into 8, how much you are getting? 4 8 is 32, and then 3 is the carry. 4 to 8 to the 16 plus 3, it is 19. You are getting 192. So 24 3s are, sorry, 8s are 192. So it is finished here only. So 24 is a divisor for 192 also, so that HCF remains the same. HCF of 72, 120 and 192 is equals to 24 only. And this method is applicable if the numbers, given numbers, are actually very big. Suppose we have to find the HCF of 2211 and 5025. So the numbers are very big. We cannot apply the prime factorization method or the division method, what we have learned at the second method, as the second method, that we cannot apply here. So what we have to do, we have to perform the long division method only. So the smaller number I will be taking as a divisor, and the greater number, comparably greater number, will be taking as a dividend. So it is coming to the 4422. So if we subtract this one, what we are getting? 3, 0 and 6. So we will be taking this one as our divisor, and 2211 will be the dividend. Now 6 3s are 18 and 6 4s are 24, which will be bigger. So let's give it by 3. So how much it is? By 3, if you multiply, 3 3s are 9, 0 and 3 6 are 18. And if you subtract, and if you want to find the remainder there, what we will be getting? 9, 2, then it's 0, then 4, 402. Now 402 will be the divisor here, and 603 is the dividend. So again 1 times it will go, and we'll be getting 201. 201, 2s are 402. Now the division is finished. So what we have got, the HCF of 2211 and 5025 is equals to 201. The divisor at the last step will be the HCF of the given numbers. So this way we have to perform the long division method to find the HCF of the given numbers. Now let's discuss some applications of this HCF, the problems where we'll be using the HCF. Suppose you have to find the simplest form of the numbers 1219 divided by 1431. This fraction is given to you, and you have to find the simplest form. So whether this fraction itself is in simplest form or not, how to decide that? We have to find the HCF of these two numbers. If the HCF is coming 1, that means the number, they are prime to each other. So it is already in simplest form. And by the way, what is the simplest form? The fraction is in simplest form when the numerator and denominator do not have any other common factors other than 1. So how to check them? We have to perform the HCF. So with the long division method, let's find the HCF, because the numbers are very big. So 1219, ones are 1219. If we subtract them, what we are getting? 212, 212. Then it's going by 5, 1060. If you subtract it, 219 minus 60, it will be 159. Then 159 will be the divisor. Ones are 159, and the remainder you will get 53. So by 53, if you divide 159, it will go 3 times. So 53 is the HCF. Okay, that means 53 is a divisor for this 1219 as well as 1431. So it is not in simplest form. Both are the multiple of 53. So to find the simplest form of the given fraction, is equals to, you have to divide them by 53. 1219 divided by 53 and 1431 divided by 53. You have to perform the divisions here at the left side. 53, if you divide 1219 by 53, what you are getting? 2s are 106, then it is 159, and it is 3s are 159. So at the numerator you are getting 23. At the numerator you are getting 23, and for the denominator again you divide 1431 divided by 53. So again 2s are 106. If you subtract it, 37 1, then last digit is 1, so it should go by 7s are 7 3s are 21, 2 is the remainder, 7 5s are 35, and 2 37. So it is done. 27 is the quotient. So once you got this one, whatever you will be getting, that is the simplest form, and it is sure that you will be getting two co-prime numbers only. Now let's see the next type of sums in HCF. Find the largest number that will divide 623, 729 and 841, leaving remainders 3, 9 and 1 respectively. So what is asked? You have to find a number. Largest number, that is another issue. You have to find a number which divides this number, and after division it will leave a remainder as 3. 623, if you divide by a number, it will leave a remainder 3. So if you, this one is the dividend by the way, then 623 is the dividend and it is the remainder. So if you subtract this remainder from this dividend, so 620 will be perfectly divisible by that number. Yes or no? So by a certain number, if you divide 623 and you are getting the remainder as 3, so if you subtract this remainder from the dividend, so you will get 620 now, and 620 will be perfectly divisible by that number. Okay, whatever you will put here by that number, 620 will be the perfectly divisible. Similarly for the second number also, if you subtract 9 from 729, that is 720, it is perfectly divisible by that number. And 841 minus 1, that is 840, will also be divisible by that number. So we have to find a number which is divisible, which is a divisor, common divisor for 620, 720 and 840. And that should be the largest also. So nothing we have to find other than the HCF of 623 minus 3, 729 minus 9 and 841 minus 1. So this one you have to find HCF. So the HCF of 620, 720 and 840 will be finding. So which method will be applying here? 620, let's apply the prime factorization now for now. So what are the common factors are there? Both 2's are there, then 5, 5, 5 and the 1. So the HCF of 620, 840, 720 is equals to 2 into 2 into 5 into 1. So that is 20. 20 is the HCF. So 20 is the largest number. 20 is the largest number that will divide each of them, leaving remainders 3, 9 and 1 respectively.